Welcome to this new chapter of geological considerations for shoreline areas. I am Professor M. Masroor from Department of Civil Engineering, AMU Aligarh. We'll be trying to understand the shoreline processes or coastal processes. What are the geomorphic features along the coastal processes? How they are working and how they are going to affect human beings and their infrastructure. As you know that sea system or ocean system is part and parcel of exogenous process, and all kinds of erosion, transportation and deposition of sediments take place along the coastal lines. Coastal regions, they are the regions where we have lot of activity, lot of interaction between the water and the land. And in fact, this is an area which greatly vary in kind of processes and intensities of processes along them as compared to any other geomorphic process. We have wave system, we have storms, we have tides, we have currents. All these are continuously acting on the land, sea bottom, and result into lot of changes along the coastline and shoreline. So let's understand first what are the different processes which are there. The most important is presence of waves, which are the result of orbital motion of water. This results into movement because of prevailing wind system. So every few seconds, these waves, they continuously impound the shoreline areas, the coastal areas. Apart from this, we have storms, which are the result of hydrometeorological conditions in a particular region. They create waves of 4 to 10 or sometimes more than 15 feet high, which result into storm surges along the coastal areas. We have movement of water in unidirectional way because of difference in salinity of the ocean water, and also because of differential heating of ocean water. The differential heating results into lightening of the water along the equator, and this light water upwells and moves towards the pole, and along the pole, because of low temperatures, water is subjected to densification. The water becomes heavier and it sinks down at the pole and it moves towards equator. So there is a continuous movement of water from equator towards pole and then from pole towards equator. In between these unidirectional currents, they are deflected because of presence of different continents. Similarly, the variation in salinity also results into the formation of currents, because wherever we have very high salinity because of influx of sediment from the land, the water becomes denser and it sinks, and when it sinks it replaces the light water. So there is a continuous movement of light water and dense water because of difference in salinity. Now these unidirectional movement of water is very important because they result into bringing of lot of nutrients, lot of material from one place to another place, and on this movement of current, not only the sea life or ocean life thrives, but also it has got ramification, lot of ramification as far as climate system is concerned. You must have heard of El Nino and La Nina. These two phenomena are also related to the movement of currents. But here we will be mostly concentrating on the action of waves, different kinds of waves of different magnitude, and the product which is resulting because of this action of waves with the land and whatever sediment available at the land. Now there are different kinds of coasts. In fact, there are coasts which are called as coast of emergence. The coast of emergence are those coasts where sea level has withdrawn itself from the land. So what you have, we have features which should be in sea, they are exposed on the ground. So this is called as coast of emergence. Similarly, we have coast of submergence, where you will find the features which should be on land, they are drowned under water in the sea or ocean. So this is all due to the eustatic sea level changes which takes place at a scale of lakhs of years or millions of years. These eustatic sea level changes are actually the result of glaciation and deglaciation cycle. Apart from this, we have another classification wherein we call Atlantic type of coast or Pacific type of coast. In Atlantic type of coast, what we have a very broad beach and then sea shelf and slope. In Pacific type coast, we have very narrow beach and it is mostly narrow sea shelf also, and mostly it is sea slope, merging into abyssal plain and then continental rise, mid-oceanic rise or mid-oceanic ridges. We also have coast which are said to be coast with leading edge. That means a coast which is present at a continental margin which is in convergent motion, and just opposite to this we may have coast with a trailing edge. So trailing edge coasts are usually of broad beach like condition, while leading edge coasts they have very narrow beach condition. These coasts, depending upon what is the power vested with the ocean wave system or the tide system, they are continuously subjected to erosion. Now it all depends that the coast is made up of rocks or the coast is made up of sand, that is loose rock material. The erosion process is carried out by hydraulic action of the wave, by solution action, by attrition, which results into formation of different kinds of features which are called as wave cut benches. We may have natural arches, natural bridges, a lot of different geomorphic features which results because of erosion by the sea waves. Similarly, with the erosion, sediment transportation takes place. Waves, they take sediment from the shoreline areas and they distribute it into the sea. So what we will find, we will mostly find coarse sediment on the beach, and as you go away from the beach towards the sea, the sediment will become finer and finer. So all these sediments, they are distributed. During high tide, what happens that the water level increases and some of these sediments, they are deposited in the backwaters, which we also called lagoons. So in fact, along a shore, we have different parts of the shore. That is, you can call back shore, where you have backwaters and lagoon. Then we have foreshore, which is comprised of beach bars and beach. Then we have inshore, where the waves are continuously coming and going. Then we have offshore, which is few kilometers away from the shoreline. Most of the countries which have these coastal areas, they are subjected to a lot of coastal storms and a lot of problems related to the erosion of the land. But at some places where we have harbors or where we have shipyards, there are some problem related to the deposition of the sediment also. The sediment deposition by waves result into shallowing of water, and if you are having ships coming to your harbors, if water becomes shallow, then they are not able to come. So sometimes we have to stop this deposition along the harbors or along the places where ships are coming. For this, we have to make structures which are called as dikes or groins. These are the structures which are just like a wall, which are made perpendicular to the shoreline so that they can stop the sediment which are coming from long shore currents, especially long shore currents. Long shore currents are those currents which are the result of deflection of waves from the shoreline or coastline. When these waves they come from some angle, they hit the coast and then they are reflected. So once they are reflected, they move linearly and with them comes lot of sediment resulting into deposition of spit bars and barrier bars, which results into shallowing of water and which is not needed. There are a lot of structures which are made into the sea. For example, lighthouses, for example, offshore platforms to extract oil and gas. So there they are to be saved from the continuous impounding of waves. So there again lot of geology and engineering geology is involved in the foundation design of these platforms, oil platforms, which may be fixed or which may be floating. And also a lot of geology and engineering geology is involved in designing of buildings along the coastal areas. There is another important aspect where a lot of geology and engineering geology is involved, that is the land reclamation. Most of the countries which are locked by sea from all the sides, they have reclaimed land from the sea. By putting waste material into the sea, they have increased their land area, that is called as land reclamation. For example, Japan has carried out a lot of land reclamation. Holland is reclaiming the land from last 1,000 years, and they have made a lot of reclaimed lands which are called as polders. So for this, what they do, they have to make small dams. Water is extracted from those areas and thrown into the sea, and this space is filled by the solid waste which is being generated all over the region or country. So land reclamation is very important, but in this land reclamation, what is important is that proper compaction of the material has to be done, because if there is not a proper compaction, then this will result into the subsidence of the ground. In Japan, in 1995, there was a Kobe earthquake, and in this Kobe earthquakes, all those buildings have failed, which were constructed on the reclaimed land because of differential compaction of the land in the aftermath of earthquakes. So land reclamation is a very important aspect. In India also, especially in Bombay, a lot of land reclamation has taken place, and this has resulted into joining different isolated islands into single units. So land reclamation needs a lot of geological considerations, starting from the base rock types, the coastal process which have to interact with that land, and the material which is going to be filled into that area which is to be reclaimed. Apart from this, we have coastal areas continuously subjected to storms and sometimes tsunamis. For this, we have to make some defenses. So the defenses which are usually used, they are either laying of riprap, rock pieces or rock boulders along the coast, or installation of concrete blocks with tripods or tetrapods, concrete tripods and tetrapods. These features, they are able to minimize the wave energy. When waves, they come and hit these concrete blocks and tetrapods and tripods, they lose their energy, and in this way they are not able to erode as much as they can. Apart from this, sea walls can also be made, but they have not been found very successful, because if water level goes above the height of the seawall, then there is a permanent flooding on the back side of the wall. But there are places where sea walls have been made with very strong foundation. that is called as bulkheads, because to make that wall withstand the continuous action and impounding of waves, the lower part of those walls have to be very strong. But the construction of sea wall is not very successful, because it incurs lot of cost, lot of money is involved in construction of these sea walls. There are two very important points which we should discuss here. Number one is salt water incursion, that is seawater moving towards land and contaminating the fresh groundwater or sweet groundwater. This is a very big issue, especially in India also, at our eastern coast, where because of reckless groundwater extraction, the groundwater seawater front has moved towards land, and slowly the seawater is moving towards land. And because of this, saline water has come in the root zone of trees, and the trees have started drying up. Now, this is mainly because of excessive extraction of groundwater. At our eastern coast, what has happened, that because of mining, reckless mining of rocks, and sometimes at some places of lignites and coals, what has happened, that they have cut in open cast mining the aquifers. As and when aquifers have been cut because of open cast mining, the water has started seeping into these mines, and all the waters have seeped out, and it is being replaced by marine or saline water. So this is a big issue which has to be taken up by a effort on a very large scale. Another important point is sea level rise. The sea level rise, because of global warming, will result into inundation of our coastal areas all along the eastern coast as well as western coast. But the most importantly, the islands which we have in Indian Ocean, for example, Maldives Island, they will be subjected to flooding very easily if the global rise in water level goes on. So this is another important issue which has to be taken in a very larger perspective, and somehow at an international level we have to reduce the emission of greenhouse gases which are actually causing the warming of the globe, which will result ultimately into melting of ice and sea level rise. So these two issues are very important which has to be taken into consideration. Another aspect of coastal management is that the infrastructure development which is taking place due to the tourism industry. These infrastructures, they are actually very close to the shoreline, because it is easier for tourists to approach those beaches and shoreline areas for recreation. But this haphazard infrastructure development is resulting into lot of loss of mangrove forest, which are the natural protective device which protect us from the storm surges especially. So the mangrove forests, they are being cut and they are taken over by concrete buildings. This is resulting into a lot of imbalance along the coastal areas and causing harm to coastal environment, its biota, as well as in long run this is going to affect our human population also, which is living along the coast. In India, almost we have 7,000 kilometers of coastlines, where we have to see that the development which is taking place should be in accordance with the understanding of shoreline and coastal processes and nature of substrate material present all along the coast. Our coastal areas are especially vulnerable to cyclones. We have lot many devastating cyclones at our eastern coast, especially in Odisha, Andhra Pradesh, and part of Bengal. These cyclones, they have wreaked havoc on the local poor populace and have resulted into lot of infrastructural loss. 1991 Odisha cyclone is the testimony of the havoc created by these cyclones. But later on, after proper understanding of the system and studies carried out by National Disaster Management Authority, in last 3 or 4 years, we have been able to manage these cyclones. For example, we have managed the cyclone Phylline, where only less than 100 people died, as compared to previous cyclones where more than 1,000 people used to lose their life. So with time, we are trying to understand the whole coastal process, and we are developing different mechanism for rescue and relief operation. The most important thing as far as coastal area management is concerned, that we should have a setback limit. We should mark an area that up to this much of kilometers there will be no anthropogenic development. So we have to have a setback limit. In fact, we have to have an area marked for no development. The areas should be marked that there should be no infrastructure development in these areas, because if you go for development, ultimately it is going to be wasted when next cyclone comes. So it is of no use to spend money in those areas. In last few years, we have been able to develop good warning system and monitoring system. We have monitored the cyclones from the very beginning. They have started forming. We have marked their movement. We have very correctly measured their landfall time, and this has resulted into proper warning and evacuation. Evacuation is the most important aspect of rescue and relief operation. Once you are able to evacuate these large number of population from the coastal areas, then you are able to reduce the losses, especially the loss of life. So rescue and relief operation starts with the evacuation, and we have to have building of different structures to house large number of people, not only people but their livestock also. So with time, our coastal management is developing and has resulted into very good work and has saved a lot of life from the annual feature of cyclone, especially along our eastern coast. Thank you.